All right. So they've given us a matrix and they've given us a row. We're going to return true if there's no zeros in that row. Since they've already picked the row, I really only need to write a column loop. So I'm just going to write one loop, even though it is a two-dimensional array. And I'm going to make sure to use a column dimension. I could put an R in place of that 0. It really doesn't matter because all of our arrays are rectangular. Now, even though I don't want zeros, I'm actually going to look for a 0, right? Because if I do find a 0 in the matrix at RC, then I know that their claim of this being a non-zero row is false. So I'll return false. If I make it through the entire set of columns and this rows and columns, whatever, then for this row, then I can say true. Okay, so for that row, if I can make it to every column checkpoint and not find a 0, then I can say true. But don't try to return true from inside the loop, right? That's going to lead to issues. And it goes false, true, false, true. Those are the same things that we see in their test case here. And I think I also put those in the main method. False, true, yeah. Okay. All right. Part B is another method called resize. This is a little tricky. Now, this wants us to remove rows from the matrix that have zeros in them. Well, we just wrote a remove method in question 3, but this is a lot different. We don't have a remove method for an array or a two-dimensional array. So you really just have to make a brand new one. And that's what we're going to do. And we don't have to actually modify the given one. We're returning one. In fact, it says right here, array 2D is unchanged. So we don't want to try to modify it. We want to make a brand new matrix instead. But here's sort of the problem that you run into right away. If you're going to make a new matrix, you have to say right away, like, how big that matrix is. So, like, I have to say, what are its dimensions? I know its column dimensions. Oh, Justin, ahead of your time's up. I know its column dimensions. So I could put here 2d0.length, and that would give it the same number of columns as the other matrix. I can't do that with the rows, though, because some of the rows are going to be gone, right? The ones that have zeros, I'm not going to keep them around. But how do I know that at the start of the problem, right? How would I make that decision right away? Well, this is a question where they give you a helper method. And so there's another method in here. It's one of these implementation not shown methods. It says numNonZeroRows. Apparently, if you give this method a matrix of ints, it tells you how many non-zero rows there are. That's perfect. That's the exact question that I don't know the answer to at the start of this problem. So in place of these question marks, I could actually just put a call to that method with the array 2D matrix. That method call is going to come back to me with an integer. And maybe I start off with 10 rows and 7 of them are non-zeros, then it's just going to go 7. And then perfect. That's exactly what I want. Okay. All right. So this gets the matrix all set up for me. But now I need to go through and put in sort of the hand-picked rows that I want. So in other words, I need to go to all of the rows that belong to array 2D, and I need to ask a question about them. Like, do you have a 0? Okay. Well, good news, again, is we just wrote a method that can answer that exact question. Do you have a 0? And that method we wrote right here is called isNonZeroRow. If you give that method a matrix and an int, a row index, it will give you a Boolean. We could make that Boolean the basis of our if statement. So give it the matrix, okay, array 2D, and give it the row. Now, notice I didn't write a column loop. That wasn't by accident, right? I don't need to pick columns. I just need to pick rows to feed this method that we just wrote, okay? And in fact, you can work with a matrix with only one index, right? So if you only use one index when you access a matrix, you get the entire row, which is perfect. So I don't really need column indexes here, but there is sort of an issue. I can't expect these numbers to match every time, because what's going to happen is as I start removing rows, the indexes are going to get off, right? Like if I take away row 0, well, now I'm going to be going into row 1 on the array 2D, but still want array row 0 for no 0. So probably the easiest way to address this would just be to make a separate index for this purpose, start it at 0, and just advance it ourselves outside of the loop, so that every time we use it, we'll make it go up 1, and we'll just let it handle things on its own. And you see there 1, 3, 2, 4, 5, 6. What you also don't see is any non-zero rows, okay? And those are the same rows that made it through their test case. The 210's gone and the 000's gone. Everything's put into the right places. The dimensions are right. Everything looks good.